Hey guys, and welcome to this video. So in this video, I'm going to be talking about OSI Layer 5, or the session layer. Let's recap what we talked about in the last video. In the last video, we talked about OSI Layer 4, or the transport layer. And the transport layer handles logical transmission of data between different processes over the network. It has several functions. It provides service point addressing, which uniquely identifies the processes. It provides connection control, which establishes a channel for communication between processes. It provides flow control, which controls how fast the sender can send data. It provides error control in order to detect and correct errors. And it provides segmentation and reassembly so that it can break down and reassemble upper layer data. Before we look at the session layer, let's take a quick look back at the OSI model versus the TCP/IP model. Now you may remember the OSI model contains 7 layers, while the TCP/IP model contains 4 or 5 layers depending on the version. Now a key difference between the two is at the top. Right? The OSI model contains 3 layers: session, presentation, and application, while the TCP/IP model collapses all into a single layer, application. Now, in the real world, the session, presentation, and application layers are all very much blurred, and as they're all implemented within the application. And that's why it makes more sense for the TCP/IP model to combine them into a single layer called the application layer. However, it is still important to learn the concepts, so we're going to talk about the session, presentation, and application layers separately. Up to this point, we've talked about all the layers up to the transport layer. And the transport layer provides a very important boundary, as up to the transport layer, it is about the delivery of data. Now, above the transport layer, it is all about the application, and the application needs to process data or do whatever it needs to do with the data, right? So between this boundary, we are handing off from the network to the application. So from this point, remember that we're only talking about the application. So let's talk about the session layer. A session is a specific occurrence of a dialog between two applications on different hosts on different networks. Now, as the name suggests, the session layer handles session management between two applications, and it provides several functions. First, it provides addressing. Second, it establishes, maintains, and terminates sessions. And lastly, it provides encapsulation into and decapsulation from the L5 PDU. Just like all the other layers, addressing uniquely identifies the session of the application that's communicating over a network. Now, different protocols can use different addressing schemes, but the most common one you're going to see is ID. Now, this is fully software-based. Remember, we're only dealing with the application, and it supports multiple sessions by using different session IDs. Once we have an addressing scheme, we can start communicating. And we start by establishing a session. Now, during session establishment, the session layer protocol negotiates parameters for the session. For example, who transmits and when they can transmit, and how much data that can be sent at a time. This is going to vary a lot between application to application. It also performs authentication and authorization. And authentication is the process of proving who you are, and authorization is the process of determining what you are allowed to do. Once a session is established, you need to maintain the sessions. And session layer protocols help ensure that communications can be restarted or resumed if it gets interrupted or it contains errors. And that's done in a process called synchronization. And synchronization is achieved by adding synchronization points to the data being transmitted. And any loss or error can be corrected through retransmission. Session layer protocols also maintain a list of sessions for different communication parties. And lastly, token management is used to ensure that there are no collisions when multiple parties communicate at the same time. Eventually, we're going to terminate our sessions, and it can happen in 2 ways. First is when the sender or the receiver asks to terminate, and that's when the sender and the receiver has finished communicating the data and would like to clean up their resources. Now, second is interruption, and interruption could be any type. It could be a network problem, it could be an application problem, or some other problem. Now, interrupted sessions can potentially be resumed depending on protocol. A lot of protocols implement a timeout mechanism where it terminates interrupted sessions so that it can free up resources and allow other parties to communicate. And if the previous party wants to communicate again, it can establish a new session. These are some of the references that I used to make this video, and thank you. Please like and subscribe and leave a comment down below. Let me know what kind of attacks you can see happening at the session layer. Thank you again, and I'll see you in the next video where I will talk about the presentation layer.